All right, so our last topic of this chapter is talking about Lewis acids and bases. And a Lewis acid can form, this is talking about the process of forming covalent bonds and describing it as being acidic or basic. And the Lewis acid is one that accepts an electron when a bond is formed. The Lewis base is the species that, when a covalent bond is formed, is donating the electrons. So you have something with electrons and you have something that accepts electrons. Then we're talking about the base with the electrons donating and the acid with the electrons being accepted. So what determines like whether or not it can donate or accept, right? So simple things, lone pairs on the acidic atom or basic atom, right? Lone pairs can cause it to act as a base. So where we see this most commonly is nitrogen. But when we're talking about carbonate, for example, carbonate ions, really the oxygen of the carbonate ions, the Lewis structure looks like this. This also has pairs of electrons, but these lone pairs of electrons can donate and act as a base. Okay, but the nitrogen of a structure has that lone pair and is neutral, as can always act as a Lewis base and donate a pair of electrons. Water is another species that can donate electrons because it has the lone pairs on the central atom. So donating is a base, okay? Acids accept, and the way we see that, there's actually three ways. I only wrote two. Uh, I'll tell you what all three are in a second. One, it has an incomplete octet. Most common example is boron. When you draw the Lewis structure of boron or even aluminum, what you find is you have this empty orbital here. It's a p orbital on the central. I remember it's sp2 hybridized, and there's an unhybridized p orbital, but it has an empty orbital, and you know that because of the octet rule. The other way that often things can act as Lewis acids is when it has a double bond like this. So let's say you have something like this. So that carbon, because it has a double bond on it, can accept a pair of electrons and then move the pair of electrons away from the carbon that makes the double bond. And so that carbon can be acting as a Lewis base. So some example type reactions, the most common one is the boron and nitrogen reaction. I have boron with its open orbital. I have nitrogen with a lone pair. It's often just drawn face to face like this. And then it goes like this. And this is actually what's known as a coordinate covalent bond. So we have a bond between the boron and the nitrogen. Now the boron will take on a negative charge. And the nitrogen with its extra bond, because it donated more electrons, will have a positive charge. Like this. But that's a Lewis acid base kind of reaction. Okay. If you have a double bond, again with nitrogens. So this is formaldehyde actually, and you have nitrogen. Let's say this nitrogen is found on the end of one of your proteins in your body, right? There's a bunch of other stuff here. R for the rest of the molecule. What it can do is it can attach to the carbon, and then what happens is this oxygen takes that pair of electrons from that bond. Now originally it had two lone pairs on it. What it'll end up being is this kind of thing. And I'll have a nitrogen and three hydrogen. Actually, it was supposed to be two hydrogens up here. I don't know what I was thinking. Now it has two hydrogens here and an R group on it, but it has four things bonded to it, so it'll have a positive charge like this. And there'll be another hydrogen over here. Okay. So that's your this is from your formaldehyde, and this is from your amine. Remember we talked about amines in chapter, I don't know, 1 or something, 2. We have amines, and they can donate a pair of electrons to the carbon. Oh yeah, well you weren't in my class, I suppose, because this is Chem 1B. But yeah, we talk about it early on in Chem 1A. Amines. They can donate a pair of electrons. This is also a Lewis acid-based reaction, and this is actually one of the reasons why formaldehyde is considered to be bad in the labs, is because your proteins in your body can begin to bond with the formaldehyde, and then your body actually learns to recognize your own proteins as being foreign material and sort of generates this autoimmune response. And over time, this response gets worse and worse and worse. Anyways, yeah, it's a Lewis acid base reaction, though, that comes from. The other kind of thing, and I didn't talk about this, the other kind of thing that can act as a Lewis acid are metal ions. And if you have a metal ion in water, right, then you have a positive charge on the iron. That implies that it doesn't have enough electrons. And you have extra electrons on the water, it can bond to the metal ion and form a Lewis acid base, like a coordinate covalent bond with the iron.